So how can I make that work? I guess I could divide it all by the dimensions of the screen, but I don't remember having to do that with the A or the E. I'll just try doing this and see what happens. And take out that. And I don't see anything, which kind of makes sense, but it's also kind of annoying. Dang, now I think I need to get the A data and the E data back. It's going to be a roller coaster. Well, it's already been a roller coaster. If I take this, I just had the A. I write it. Then just print its points. I'd assume that this wouldn't print it in normalized device coordinates. I think what it is that the A just happens to be small enough that it fits. So I'm gonna write this to the data file. And this will be A points. And add in the commas. Okay, and I'll try to import that. And here, read the A points and try to text render this. Okay. So it is being distorted. It's not in normalized device coordinates, but the A happens to be small enough that it just works. The next question is, how can I get this into normalized device coordinates so I can render it the same way on both? I think what this would take is saying the points equals this, then A points divide equals, maybe times equals. I have to divide by, I'll do divide. mp.array. Then I'll need the width in Manim coordinates. Or is that divided by 2? I think it's just the width. And the height. The depth, I'll just leave at 1. Then I'll try to print this. Oh, that's the wrong thing. I wasn't trying to overwrite that, but whatever. Oh, that's the wrong thing. I wasn't trying to overwrite that, but whatever. And it doesn't have the commas again. I'll do the add repper here. Okay, now it at least has a comma. It probably won't be long before I start actually using doing the thing you're supposed to do, and using from file and to file. But not yet. Okay, then if I try to text render this, it is in the same place as it was in Manim. Although it's not anti-aliased, so it looks terrible. Okay. So then I have something, this here. I want to gather that data in an array too. And actually, I think one big two-dimensional array is okay. Which is kind of ironic, since I didn't want to have that before. Wait, no, just kidding. It's not okay. Because I'll have to compute their bounding boxes separately. Okay, so what I'll do... Child and text.subobjects at 0. And this, what I'll do, the same thing I did before, output.append this. That to list, I guess. So now I have a list of lists which contains all the points. Okay, now I don't have to play it at all, actually. I'll just print the repper of the output. And not destroy my data file. Okay, I think that's fine. Now I'll append this to the data file. Wait, I did the wrong one. This is the wrong scene. Okay, text test number 2. Append this one. Wait for my computer to struggle through that. I can tell I'm doing something wrong because my text editor is struggling this hard. And I have a pretty beefy computer here. So this is most definitely not what I should be doing here, but you know. Okay, now it's on separate lines. I can call this something data or something like that. I wonder if I can format this Is it like them.lsp.form.lua maybe? No, I don't know. There's a way to like trigger lsp.form.lua maybe? No, I don't know. There's a way to like trigger auto formatting where it won't time out, but I don't remember it. Okay. Hopefully, now in the text rendering algorithm, I can import something data. And then here, I could use something data at 0. If I render this, there's nothing again. Oh, well, it isn't a normalized device coordinates. Which is actually extremely annoying. I can fix that by going back to this test 2 and then like doing this. Equals this without the to list. That's the child points. This is how I divide it. Then I would append this, just the child points. But at this point, I think this I should probably do the to file and from file. So let's hope that's not too difficult to do. So file object separator. And a format. Okay. So what to do is with open. I'll do text rendering slash something data dot npz, I guess, as f. Output dot to file f. Okay, I'll try writing that way. No such file as or directory. Is it W? Or maybe it's A that lets you open a file that doesn't exist. W plus. This has no to file. Did I do to list or something here? Oh, I did this. So here I would have to have it be a 3-dimensional array. Dang. Because that's what I wasn't able to do before. np.stack can append the 2D arrays to the R list using list.append. Then after you're done, wrap it. Yeah, okay. Guess that's fine. I'm sure this is slower since it's using a Python list. But I'm only testing anyway. 9 by... Can I write object raised to a file in binary mode? Did I open this in binary? Can I write object raised to a file in binary mode? Did I open this in binary mode? And then also, the shape is wrong. Why is this a 9-dimensional array? Okay, I'm gonna try this from here. So this is in fact a 2-dimensional array. Yeah. So what did this indie array at r.shape? So this just isn't what happened. Yeah, that just didn't work. Okay, I guess I'll try that np.stack. Thanks. All input arrays must have the same shape. Okay, I'm starting to get the feeling these have to be... that this can only be done with a regular Python array. Let me just do a toList here so that it's a regular Python array. So now output contains the data I want, but it's a Python array. But I'm just gonna find a way to write that. I think I have to use pickle or something, yeah. And then I'll just do this verbatim. And my copy and paste didn't work. Actually, this as F, this is what I wanted. I just want write bytes. Pickle.dump whatever. To F. Okay, this time, for sure, oh, it has the wrong name, NPZ, whatever. Great. So now I can read this in here. With open of whatever as FP. And it's going to be very similar to Basically, just copy from this. Let's read. And pick all that load. Okay. So now, hopefully, wait, where's this? This should be normalized. And I read it into the text rendering, so I would expect this to render something. Can I import name something data? And we get something. Oh, we get an S, which eventually will be something if I did the rest of them. Oh, that was an enormous pain. So then I could do... if I concatenate... something data at 0, and I'll do at 1. Then at 2. Okay, and if I did all of these, then I'm confident I'll get something. Since that's what's happening now. Cool. So anyway, I can get back to collision detection that I was doing in the first place. Can I just do star of something data here? Guess not. Like tuple star of whatever. Resource hogger. Okay, I mean, right now I'm only doing it for testing, so it isn't a huge thing. Tuple expected at most 1 argument. You can't unpack. Can't unpack. You mean... I'm not sure what you mean. I mean, I found a way to do it. Oh, you mean like with a star here. I see what you mean. But okay, all of this I don't need anymore. And this I don't need anymore. Yeah. Guess I'll put this at the top. Okay. So now that I have this something data, this would be like basically having the list of sub-objects that I want to render together. And I have to say, okay, for each of these, do any of them intersect? So I guess that would be an n squared operation. Wouldn't it be a large n squared operation? It'd only be n squared over the number of letters you pass in. Which, like, at the high end, the very high end, that'll be like probably 40, 50. Maybe looking at, well, at 50, that'd be kind of a lot. But I don't think that would be like a significant slowdown. So let me try to compute their bounding boxes. Which in Manim they'd already have those bounding boxes. So I'll say a list of get bounding box points. I'll say curves in something data. This you can actually do this by returning 2 points. It turns out to be fairly straightforward. I should just search nins, I think. Yeah, you just call this function. The list dot min, this is the lower left. Then dot max is the upper right. So say min equals curves dot min at 0. Let's call this lower left. Upper right. Okay. So now I have the points and I have the bounding boxes. And in Manim, everything up to here would just be handed to you because those objects would already have the bounding boxes. So now the question is, given those bounding boxes, do any of them intersect with each other? And I can easily do that in n squared. I think there's a faster way to do this with segment trees or something like that, which won't be in squared, but the data structure is much more complicated. Or maybe there's something easy I'm overlooking. No, it's essentially gonna do this. The left. Yeah, this is fine. I could probably look more into finding the wave to see if, given a list of bounding boxes, does something intersect with anything in the list? But for now, I think I have to do something like render, like have this render list. And then for box and bounding boxes, if it doesn't intersect with anything in the prior, anything with a with a lower index than it already has. So I have to do I box and enumerate. If any I'll do like box intersection of box and prior box. Prior box in bounding box